A non-linear data structure in which the item are arranged in sorted sequence and it is used to represent the hierarchical relationship existing among the several data items. Each node of the tree may or may not have pointing the next more than the one node. A theoretic definition of the tree. Theoretic definition, it is the set fine set tree one of the most data items node such that there is a special data item is called the road. It is the remaining data which are pointed and the non-mutually recursive subset. Recursive subset is stored with the cell tree and they are called the subtree. Here, tree terminology root, the first node in the hierarchical arrangement of the data item is not root. Each data item in a tree is called the node. Degree of a node, it is the node of the subtree of a node and given tree from the figure here. The degree of a node A, node 3, degree of a D2, degree of a node F1, degree of a node I is equal to 3, degree of the tree, it is the maximum degree of the node in the given tree. Here the degree of a tree is 3. Terminal node, the node with the degree 0 is the terminal node. Here the S, I, G, H, X, L, M are the terminal node. A non-terminal node, any node except the root whose degree is not 0 and is called the non-terminal node. Siblings, the children node of the given parent node is called the siblings. F and R the siblings parent node. B and K, L, M are the siblings of the parent node. I and so on level. The entire tree structure is level in short so that the node root node is always with the edge is at the level 0. Part 3, it is the sequence of consecutive leads. It is the connecting line of the two node or depth or the at the maximum level of many main node in a given tree. Here the depth of the tree is for the forest. It is the set of disjoint tree in the given tree. If we remove it, then it becomes forecast binary tree is a finite tree set. Binary tree set. A binary tree, the single tree is called the root and the two disjoint binary tree, the left and the subtree, right subtree. In the binary tree, the maximum degree of any node is almost 2 and each node having 0, 1 and 2 degree nodes. Strictly binary tree if every the non-terminal node in a binary tree consists of the non-empty left subtree and the right subtree, then the search tree is called the strictly binary tree. Completely binary tree, the depth of the d with the binary tree and that contains exactly the node and the 0 2 and the node level 1 and the node level 2 and so on. Complete binary tree, the complete binary tree depth, the binary tree, extended binary tree, a binary tree is called the extended binary tree. If every node of the tree has a 0 or the two children, it's called the two tree. Algebraic expansion representation tree. An algebraic expression can be represented in a binary of the two, which left and right elements will be operand in the expression and the parent of the child representing the other algorithm. Note of the order precedence all the expression in the parenthesis. One to be adjusted. First exponential will become no division and multiplication will be the next order of the precedence. Subtraction and the abstraction will be the last route to be the precedence. C plus A plus C minus D into E. A plus B minus C D into E. A plus B into C. B plus D into C into E. A representation of the binary tree A, B, C, D, E, G, H, F, structure node, char data node, IC child node, rechild, binary tree transfer, while the transferring the tree denoted by the F. Then the tree will seek combination of the transfer NRL, NLR, NRN, LNRR, NLR, NLR, pre-order transfer, LN post-order transfer, LNR in-order pre-order transfer, LNR visit the root node transfer, the left sheaf of the tree in the pre-order transfer, the right sub tree in the root in the pre-order PTR struct node PTR if the PTR null printf d% PTR data left order PTR in child R child power pre-order PCD in order transfer INR transfer the left subtree of the root in order visit the root transfer the right subtree of the root in order struct node if pre null in order pre child INR PTR data in order PTR child post order transfer LRN transfer the left subtree in the root into the post order transfer of the right subtree of the root into the post order visit the root post order PTR strict node PTR PT null post order PTR child R child data post order question construct of binary tree from a given algebraic expression in the show a into b a into e h f a into a e h a e f in order post order creating a binary tree. Create a pre-order A, B in order, pre-order, postfix pre-order, insert E, insert C, insert A, B, C, D, E, insert D, A, B, H, I, J, G, D, H, E, K, insert C, insert I, binary search tree, a binary search tree, the binary tree which in which each node has a value greater than every node in the left subtree, less than every node in the right subtree. Position construct the binary tree from a given data item 50, 30, 60, 22, 38, 55, 34. Construct the binary tree 2017, 2017, 6, 8, 10, 27, 18, 13, 12, 5, 6. Deletion operation in a binary tree leaves easiest to delete. Let's set the pointer from the parent if any to the null node with the child fairly easy replace the node being deleted by its in order successor. Delete 85 80 since the 85 had no children so we cannot delete it. Simply it by giving a null value its parent right pointer thus the tree becomes deletion 50 since 50 has only one child, so we can delete it by giving the address of the right child and its parent left pointer. Thus, the tree become deletion 75 since the 75 has the two children. First, we delete the item which is an order successor here. The 75 80 the order successor ABL tree, balance tree, GM. And the tree procedure for the insertion of the node into the ABL tree. ABL tree or the balance tree. ABL tree is a binary tree where the height of the left and the right subtree at any node will be maximum difference where the ABL tree भनेको the height of the left and the right subtree at any node with the maximum difference of one is node ABL tree. Balance factor of the node is defined as the difference between the left subtree and the right subtree. The balance factor height of the subtree height of the right subtree or node is called the right heavy and the height of the right subtree one or more than the height of the subtree more than the height and it is equal subtree or node is called the balance. If the height of the right and the left subtree are equal, the balance factor will be 1 for the height h and the right for height 0 and the balance more trust in the ABL tree. And the ABL tree is not have only three value of the balance factor which are 0, 1 and minus 1. Procedure for the insertion of the node into the ABL tree. Insert the node in its proper place in the binary tree. ABL rotation, AB procedure for the insertion of the node into the ABL tree. Insert the node, calculate the balance factor of all the node on the part of starting the from the inserted node to the node root node. If the value of balance factor of each node or in sparse, if the tree has become unbalanced after the insertion and the tree is rotated about the pivot node and to achieve all the property of the ABL tree, left to left rotation. Insert pivot node if the node is inserted on the left side of the subtree where we perform to the left, left rotation 1 2 5 10 18 12 15 20 24 16, right to the right rotation 10 15 15 16 20 26 35, insert 39 10 15 15 16 20 26 35 38 39. If the node is inserted on the right side of the subtree, then we can perform the rotation 10 15 15 19 16 35 26 38 39, left to the right rotation. If the node is inserted on the right side of the left subtree, we can perform the left to the right rotation. If the left to the right rotation, the operation involves the two steps. First, we perform the right to right, and from the next pivot point, we perform the left to the left to the right rotation. Insert 10, 15, 18, 20, 19, 26, 38. 10, 15, 18, 19, 20, 24, 26, 35, 38. Right to the right, 10, 15, 18, 19, 20, 26, 24, 35. Construct the ABL tree from a given data. Insert 50, insert 40, insert 35, insert 58, and insert 48, 40, 58, and rotation left, rotate to the left rotation. ABL step 1, 38, 45, 48, 42, 52, 58, step 1, 35, 40, 48, 50, 58, 42. Insert 60, 48, 40, 35, 50, 42, 58, 60, 35, 48, 40, 35, 58, 60, 50. Insert 30, 48, 40, 35, 30, 58, 50, 60. Insert 33, 48, 58, 60, 48, 42, 35, 30, 33. Step 3. Um, Step 3, 48, 48, 48, 48, 48, 48, 48, 48, 48, 48, 48, 40, 33, 30, 48, 35, 58, 50, 60, 48, 33, 30, 25, 40, 42, 35, 58, 50, 60. Insert 25, 48, 40, 33, 30. Tree offline tree insert 25, offline tree internal node external node, extended binary tree total path length, internal node pi 0 1 2 3 2 plus 3 9 total path of the external node pe 2 3 3 2 4 4 3 plus 3, if the external node weight w2, then the weight is path, length of the external node. Let us take n weight wn and w2. WN, take a two minimum weight and create the subtree. Suppose WN and W2 are the two submit weight. Again, with will be the subtree. Now the remaining weight W and W2, W3 and W4. Create the subtree at the last AB. 16, 11, 7, 20, 25, 5, 16, 12, 5, 7, taking the node 23, 11, 12, 5, 7. Now the element are taking the two node with the maximum weight 16 and 16, 32, 16, 43, 23, 22, 5, 7, 11, 57, 32, 25, 16. 60, 157, 32, 43, 20, 23, 12. Total path P1 to 3 4 plus 12 PE, balance tree. It is also known as the balance or tree. The height of the tree must keep your minimum. There must be no impedance of tree above the leaves of the tree. The leaf of the tree must be all at the same level. All the node except the leaf must be have at least some minimum number of the children tree order. All the leaves node will be at the same level. All the leaf node contain the minimum n minus 1 key. Writes to tree when the new key is to be inserted into the full node. Then I split the node with the minimum value, median value. The insert into the parent node. In the case the parent node is the root and new node is created 100, 30, 85, 130, 180. 10, 20, 40, 50, 51, 80, 90, 110, 120, 141, and 61, and 60, 190. 240, construct the B tree. B tree, insert the 10, 10, insert 70, insert 10, 60, 16, insert 20, 10, 20, 60, 70, insert 100, 10, 60, 60, 10, 20, 70, 100, 10, and insert 40, 60, 10, 10, 20, 40, 80, 30, insert 80, 70, 80, 110, insert 30, or insert 130, 130, 130, in 40, insert 100, 70, 80, 10, 20, 40, 100, 60, 100, insert 10, 20, 40, 50, 10, 80, 100, 73, 60, 100, 190, 20, 40, 50, 70, 80, 100, 130, 190, 60, 100, 10, 20, 40, 50, 70, 80, 90, 100, 130, 190, 60, 100, 10, 20, 40, 50, 70, 80, 90, 100, 130, 180, 190, 70, 80, 90, 100, 130, 30, 60, 100, 180, 10, 20, 40, 50, 70, 80, 90, 100, 130, 30, 60, 100, 180, 10, 20, 40, 50, 40, 80, 90, 10, 110, 120, 190, 30, 60, 100, 180, 10, 20, 40, 80, 70, 80, 90, 110, 120, 130, 140, 190, 240, 130, 130, 180, 10, 20, 40, 50, 70, 80, 90, 110, 120, 140, 160, 190. Deletion in the B tree node is a leaf tree node if the node has a max then the maximum number of the key if it has only the maximum number of key then first we see the number of key leaf node if now the parent has less than the minimum number of the key then the same thing will be repeated until we get the node the node is a non-leaf in case it will be key will be deleted then the processor or the successor key will continue in this place if the both node of the precedor and the successor key are the minimum number of the key, then the rate of the precedor and successor key will continue 100, 30, 60, 100, delete 190, 100, 30, 60, 100, 100, 30, 60, 30, 60, 70, 120, 140, 170, 125, 70, 130, 180, 110, 20, 30, 50, 180, 90. Chapter 8, insert 659 767 02157 728 102 161 899 920 44 744 384 344 973 905 999 344 sorting is the storage of the data in sorted order and it can be in ascending order descending type internal sort external sort the sort taking algorithm transfer with the given data using the insert and pass 1, pass 2, pass 3, pass 4, pass 5 selection sort algorithm passing. Okay, this much for today for it.